Hey, Jonathan here at Colfax Math. This is a practical math station. I teach high school math in shop. I was a contractor before I started teaching. And today's video, I'm going to go over math skills for the plumber's apprenticeship exam. I've done some videos before, but today I'm going to do this test right here as a practice test, and I'll put a link to this test in the description.
Measure the height. Yeah, no, measure the width from here to here.
Laminated overnight on a CNC cut sheet. All right, well, I'm going to get started on this plumber's apprenticeship math exam. The problems aren't too hard, and they'll probably come back to you pretty quickly as I review them. What I would do on this video is I would take this test, which is in the description, print it out, have it in front of you, watch the video for a little bit, pause it, and then do the problem before I do it. Do the best you can, then hit play and watch how I solve the problem. You could do 3 problems at a time, a page at a time, or you could do that after every problem. It starts out with kind of basic arithmetic without a calculator, and I'm going to go through all of it. I'm going to go really slow, so you might want to fast forward through some of those portions, or you might want to rewind and watch those portions again. So again, this test is for the plumber's apprenticeship basic math exam to get started in the plumbing trades. And I'm going to work my way through this test. I would print this test out. I would do the problem, with the video pause. And then when you're done doing the problem, then hit play on the video and watch me do it and make sure we're doing the problems the same way. Hopefully this will help. This is a practical math channel, so if you're new here, think about subscribing. And certainly comment below. I'd like to hear how this is going. This is a math review for plumbing apprentices. This is level 1 plumbing students should be able to do this pre-test, and this is a check of math skills. It's from the review book, Pre-Apprentice Training, a test preparation manual for the skilled trades by Jack Martin and Mary Sarah. I'll put a link to that book in the description as well. So the first problem, add the following numbers, 14, 108, 1027, 6, and 339. This is kind of about place value or place order. So you got to line them all up in the right place. So here's 14, 108, 1027, 6, 339. So they're all lined up with the ones lined up, the tens lined up, the hundreds, and the thousands. Then I'm going to add straight down that column. 4 and 8 is 12, plus 7 is 19, plus 6, 25, 25 and 9 is 34. So 34, carry the 3. Now I'm in the tens place. 3 and 1, 4, 5, 6, plus 3 is 9. Then I go to the hundreds place. 1, a 0, and a 3 is 4. And there's in the thousands place, there's only that 1. So 1494. So that's the answer. What I do is I print this test out from the from the link in the description, and I do the problems before. You should do the problems before I do them, and then after you do them on your own, then go ahead and check your work. Okay, this next one is similar in that is place order, except for its decimals. So I'm going to line it up the same way. Let me use some separate paper here. Add the following numbers. So I have 1.06. The decimal place has to line up on all of them. So the next one's 113.94. The next one's 0.642. And next one's 2.009. So again, those decimal places are all lined up. This is the ones place, the tens place, the hundreds place. Then on the right side of the decimal, this is a 1/10, 1 100ths, 1 1,000ths. So I start on the far right, and I'm going to add and carry the same way. 2 and 9 is 11. Carry the 1. 6 and 1 is 7. Plus 4 is 11. Plus 4 is 15. Carry the 1. 1 and 9 is 10. 16. Carry the 1. Now I'm in the ones place. right here. I bring my decimal point right down, and then I carry that 1 up here. 1 and 1 is 2, plus 3, 5, plus 2, 7. Nothing to carry. I bring that 1 from the tens place down, that 1 from the hundreds place down, and I get 117.651. So that's the second problem. Okay, the third problem, subtract 1026 from 2003. So 2003 goes on the paper first, and I'm subtracting 1026 from it. So subtract 1026 from 2003. So this is about borrowing, also kind of place value. You can tell because all these zeros are here. 3 cannot subtract 6, so I got to borrow from here. But there's nothing to borrow from here, so I got to start all the way at the thousands here. So I'm going to borrow 1,000 from here and make this 1 1,000ths, and I'm going to make this 10 100ths. And then I'm going to borrow from this 10 to make this 9, and then make this 10 tenths. So this is 10 tenths. I'm going to borrow from that to make it 9. I'm going to take that 10 and put it here to make this 13. So now I have 13 minus 6, 7. 9 minus 2, 7. 9 minus 0, 9. 1 minus 1, 0. So my answer is 977. And that's the third problem here. 977. The first one was 1494. And the second one was this one here, 117.651. All right, let's move on to the fourth problem here. On this fourth problem here, this is similar but with decimal place. You've got to keep track of that. Subtract 56.078 from 87.64. So that 87.64 goes on the page first, then subtract 56 from that, so it goes below. So 56.078. These are all supposed to be done without a calculator, and the math idea on this one, again, is borrowing in place order. So the big idea is that decimal places line up and that you're borrowing. So there's nothing here, so it must be a 0. Right, for 640, 0 minus 8, I can't do that, so I got to borrow 10 from here. So I borrow 10 from here, this becomes a 3, that becomes a 10. 10 minus 8 is 2. 3 minus 7, I can't do that, so I got to borrow 10 from here, that becomes a 5, and that becomes a 13. 13 minus 7 is 6. 5 minus 0 is 5. My decimal place comes straight down. 7 minus 6 is 1. 8 minus 5 is 3. And I end with 31.562. So that's this problem here, number 4. With significant digits, you probably round that to 31.56, but 31.562 is correct. But because there's only 4 significant digits, they round it to 31.56. Okay, down to number 5 here. Multiply 43 by 7. Multiplication is commutative, meaning it doesn't matter which order you go in. So you could do 7 times 43 or 43 times 7. Again, it's all about carrying without a calculator. I like the larger number on top. I'm going to do 3 times 7. 3 times 7 is 21. I carry 2 up there. 7 times 4, 28. Plus these 2 is 30. So I get 301. So answer number 5 is 301. All right, you might want to pause the video for a second, stretch your legs before we move on to page 2. On page 2 right here, also, I know I said this a lot, but pause the video, try and do this one yourself, and then unpause it and watch me solve the problem. All right, let's move on. Page number 2, number 6, multiply 1137 by 56. So we're multiplying. Again, this is all going to be about keeping things in order and place value. I'm going to multiply the ones digit here all the way through carrying. Then I have a placeholder and multiply the 5 through, and then I add those two rows together to get my sum. So let's do that. 6 times 7, 42. Carry the 4. 6 times 3, 18. Plus 4, 22. Carry the 2. 6 times 1, 6. Plus 2, 8. And then 6 times 1. So that's 6 times 1137. I'm going to hold a placeholder here. And now I'm going to do the tens place, because this is the tens place, so it needs to start over 1 unit this way. 5 times 7 is 35. Carry the 3. 5 times 3 is 15. Plus 3, 18. Carry the 1. 5 times 1, 5 plus 1, 6. And 5 times 1, 5. Then I got to add these two rows together, 2 and the placeholder 2. 2 and 5 is 7. 8 and 8 is 16, carry the 1. 6 and 6, 12, plus 1, 13. 13, carry the 1. 5 and 1 is 6. So I get 63,672. So number 6 is 63,672. On to number 7, 11.007 times 108.2. So I'm actually not going to look at the decimals until I'm completely done with this problem. But I do note that the decimal is one place over here and 1, 2, 3 places over here. So it's going to have to go over 4 places in my answer. I might just put a little note to myself so I remember to do that. Otherwise, this multiplication will be just the same as the other one. I need to have placeholders for the tens, the hundreds, and the thousands. And then I'm going to sum those 4 rows up, get my answer, move the decimal place over 4 places. So if I'm adding decimals, right, like that, if I'm adding them, they have to be lined up. But when I'm multiplying, I just keep track of how many places over they are. So let's go ahead and multiply 11.007 by 108.2. 2 times 7 is 14. Carry the 1. 2 times 0 is 0 plus 1. 2 times 0. 2 times 1. 2 times 1. Now I'm going to move on to the 8. So I'm going to have a placeholder here. 8 times 7, 56. Carry the 5. 0 plus 5. 8 times 0. 8 times 1. And 8 times 1. Now the next one over the 0, so I'm still going to put these 2 placeholders in here. 0 times 7. 0 times 0. 0 times 0. 0 times 1. 0 times 1. Now I'm finally at this 1. It's 4 places over, so I need 3 placeholders. And then 1 times 7, 1 times 0, 1 times 0, 1 times 1, 1 times 1. I'm trying to stay pretty organized here in my columns and my rows. I am pretty organized. So I'm going to add these up. I'm going to add these 4 rows right here together. 4, 1 and 6 is 7, 0, 5, 0 is 5, 2 and 7 is 9, 2 and 8 is 10, carry the 1, 8 and 1 is 9, 0 and 1 and 1. Looks like some giant number, but I got to remember I got my decimal place 1, 2, 3, 4 places over. So I start here and I go over 1, 2, 3, 4. So there's where my decimal place goes. So I have 1190.9574, but I only have 4 digits up here, or 2 places after the decimal. So I'm going to round. So I'm going to take this answer of 1190.9574 and round it up. I'm going to round this up to a 6 because this is above 5. So I'm going to round it to 1190.96. So the answer to number 7 here is 1190.96. So I rounded up because this 7, I brought this 5 up to a 6 to round over to get 1190.96. All right, let's keep going. Let's see here, number 8. 1064 by 8. So divide 1064 by 8. So that's what it's saying. It's saying this number 1064 is getting divided by 8. So same kind of thing. It's all about place and keeping track of where everything is. So 8 goes into 1, it doesn't. 8 goes into 10 1 times. The 8 goes below here. 10 minus 8 is 2. Bring down the 6. 8 goes into 26 3 times to give me 8 times 3 is 24. Subtract here, 6 minus 4 is 2. Bring down the 4. 8 goes into 24 3 times. So 1064 divided by 8 is 133. Or what I'm saying is 133 times 8 gives me the 1064. Hopefully you're doing well here. I'm sure, the fact that you're just working at it's, a big plus right there and getting it done. This is kind of similar to the last one, just incorporating decimals into it. So they all kind of take one step at a time. So divide 109.86, divide that by 10.3. I want to get rid of this decimal place here, so I'm going to push it over 1. If I push this over 1, I push this over 1 here. My decimal is going to go right up there. I move it straight up. So I'm going to do 103 into 109. And it's going to go in there 1 time. I got 103. Then I do 9 minus 3, 6. Bring down the 8. 103 into 68. It doesn't go into 68. So it doesn't go in there. I'm going to bring down the 6 now. Bring down the next number down, 6. 103 into 686. That'll be 6 times. What is that? 618. And if you didn't get that 6018, you just do 103 times 6 to get 18. Oh, wait a sec. I did that wrong. No, I didn't. 6 times 0, 0 plus 1. 6 times 6, 618. Then now I'm going to have to subtract, and I'm going to have to borrow 10 from here. This is going to become a 7. This is 16. 16 minus 8 is 8. 7 minus 1 is 6. And then 6 minus 6 is 0. So then here's a decimal place. So I'm going to bring that 0 down. 103 and a 680 will also be 6. And if it's 6, it's 618 again. 618. Borrow from here to get 7. 10 minus 8 is 2. 7 minus 1 is 6. Bring down another 0. I see 618 is 6. So 1018. 6 times 103 will be 618 again. So I think that's probably as far as we'll go. 3 decimal places after the 10. So, you could keep going that way. But if you divide 109 by 10, it's going to work out to be 10.666. And that kind of makes sense. Even if we rounded 10 times 10, it's pretty close to 100. So, actually, that's closer to 11. Okay, moving on to number 10. Add the following fractions. So the key to adding fractions is a common denominator. So we have to have a common denominator, add these fractions. We have 1/4 plus 1/8 plus 3/16 plus 1/2. So I'm looking for the number that all of these will go into, and they will all go into a 16. So I got to make the common denominator 16, so that this one's going to stay the same because it's already a 16. How do I turn 2 into a 16? I multiply it by an 8, but I can't just multiply something by an 8. I have to multiply it by 8 over 8, so I don't change the value of it. So 1/2 is the same thing as 8/16. 8/16. And then I'm going to do the same thing here. I'm going to multiply this by 4 over 4, because I want a 16 on the bottom, but I'm going to multiply it by 4 over 4, which is 1, doesn't affect the value. So this one becomes 4/16. This one I'll multiply by 2 over 2. That'll give me 2/16, 3/16, and then here I have the 8/16. Now that I have a common denominator on the bottom, the way I add fractions is I add across the top, and I keep the common denominator on the bottom. So 4 plus 2 is 6, plus 3, 6 and 3 is 9, 9 and 8 is 17. So I end with 17 over that common denominator is 16, which is a good answer. It's an improper fraction. Or you could convert that into a mixed number and say that 16 goes into 17 one time with 1 left over. So 1 and 1/16 is the equivalent of 17/16. Either one of those is a good answer. So number 10 is 1 and 1/16. Moving on to 11. Multiply the following fractions: 3/7 by 5/9 by 1/2. I guess if you stuck with me so far, I probably don't need to say this, but even though the print's really small, if you printed this thing out, hopefully my writing's big enough and you can see what's going on. So adding fractions, common denominator, same with subtracting. Multiplying, I just multiply across the top and across the bottom. So across the top is 3 times 5 times 1, 15. Across the bottom is 7 times 9, 63. 63 times 2 is 126. So 15 over 126. Looking for numbers that'll go in there and reduce any, and I think a 3 will go into both of them. So the way I could figure that out is that 15 is divisible by 3, and 126, is that divisible by 3? 8, 9, it is divisible by 3. So 3 will go into 15 5 times, and 3 will go into 126. 3 will go into 126. 3 into 12, 4. 42 times. So 15, 126 is correct. 5, 42nds is correct. Usually the reduced fraction is a better choice. And I'll show you another way to do this same problem a little bit easier. So let me do this one other way. I have 3/7 times 5/9 times 1/2. So another way to do this is see if any of these numbers cancel, because I'm multiplying. So 3 will go into 3 one time and into here 3 times. I don't think anything else will cancel, but now I can multiply across the top to get 5. 7 times 3, 21 times 2, 42. So you could cancel when you're finished like this, or you could cancel in the problem with multiplication. All right, let's turn the page. Now I want to pause, stretch your legs here a second, then come back. Do this problem 12 first before I do it. All right, so coming back, divide the following fractions 1/4 by 1/2. So this is kind of a hard one just to decode the words. So what I'm saying is divide 1/4 by 1/2. So that's what it would look like, a fraction and a fraction. I think of this fraction would fall over. So what I'm saying is 1/2 into 1/4. Or the other way to divide fractions is to say 1/2 divided by, 1/4 divided by 1/2. the way you divide fractions is you multiply by the reciprocal. So you take this division sign, turn it into a multiplication sign, and when you turn this into a multiplication sign, you flip that over. So you turn it into 2 over 1. Let me say that again. The way you divide fractions is you multiply by the reciprocal. A reciprocal is that thing flipped over. So a quarter divided by a half is a quarter times 2 over 1. Then I just multiply across the top, multiply across the bottom, and get 2/4, which is equal to 1/2. That one's not an easy one. Just kind of decoding it's a little tricky. But 12 is 1/2. Okay, on a 13, we'll do this one the same way. 3/16 divided by 1/8 is going to be 3/16 times 8 over 1. I can multiply across the top and across the bottom, or I could reduce now and see that 8 and 16 could cancel. 8 goes into here 1 time, 8 goes into here 2 times. Then I multiply across the top to get 3 over 2. So that's a good answer. 3 over 2, or as a mixed number, 2 goes into 3 1 time with 1 left over, and I'm left with 1 1/2. 1 1/2. So that's it kind of for the arithmetic section. And now I think we're moving into geometry. This is actually one of my favorite subjects here. Number 14 says a right triangle. So let me create that picture. A right triangle. So right means it has a right angle of 90 degrees. Contains one angle of 46 degrees. What is the size of the other angle? So what's the measure of this angle? You need to know that all 3 angles in a triangle add up to 180. Or you need to know that these 2 angles here add up to 90. So you're saying 46 plus what equals 90? So you subtract 46 from both sides and get 44 degrees. 44 plus 46 is 90. These 2 angles add up to 90. So this answer is 44 degrees. That little circle is a degree mark. Convert 5/8 to a decimal. So I want to turn 5/8 into a decimal. So the way I turn 5/8 into a decimal is, that's one you could know that a quarter is 0.25 or an eighth is 0.125. So a half would be 0.5. And then a half is, 5/8 is 1/8 over a half, so it's 0.625. Or the other way you could do it is you could just drop this fraction down this way. It's going to fall to the right. 8 goes into 5. Well, it doesn't. So we've got to put a decimal point in there. 8 goes into 50 6 times to give me 48. Subtract 48 from 50 to get 2. Bring down the 0. 8 goes into 20 2 times to give me 16. 20 minus 16 is 4. Bring down the 0. 8 goes into 40 5 times. So it's 0.625. That decimal goes straight up there. So number 15 is 0.625. Number 16, how many millimeters in a meter? Well, that's going to be 1,000. A mil is 1,000 meters. So how many millimeters in a meter would be 1,000? 1 imperial gallon is equal to how many liters? I don't know. I mean, the only way to really know that is to memorize it. It's actually 4.54. That's just something you have to memorize. 1 gallon is 4.54 liters. Yeah. There's really no way to know that except for by memorizing that one. All right. Again, I take a little break and come back. Pause the video. Video's turning into an epic long video. But we'll just keep going. Hopefully you're breaking it down into pieces, doing the problems before I do them. All right, let's see number 18 here. A plumber cuts 3 sections of pipe from a 12-foot length. So we're starting with the 12-foot length. 12 times 12, 144 inches. The length of the sections are 33 and 3/8, 56 and 5/8, 39 and 7/8. What is left over from the full length if the kerf, the saw cut, is an 1/8 inch wide? All right, so we have an 1/8 inch kerf of the saw. So I think what we're going to do first is we're just going to sum this up first, and I'm going to split this into a few different problems. I'm just going to add the fractions up first. So I'm going to add 3/8. I'll have a common denominator here, so that's good. So 3/8 plus 5/8 is 8/8, plus 7 is 15/8. So I have 15/8. 15/8 is the same as 1 and 7/8. So my fractions add up to 1 and 7/8. And then I'm going to take this 1 and put it up here because it's a whole inch, and then I'll get rid of it here. So now I have 1 plus 3, 4, plus 6, 10, plus 9, 19. Carry the 1. 1 and 3 is 4, plus 5 is 9, plus 3 is 12. So I'm a total of 129 and 7/8. So those are my pieces. If I think about this pipe right here, right, it's 144 inches long. I cut my first piece, and then I make a 1/8 inch cut to cut off that first piece. Then I cut my second piece, and then that's also an 1/8 inch cut. Then I cut my third piece, and that's also an 1/8 inch cut. So I'm losing 3/8 of an inch. So I'm going to take those kerfs of 1/8 and add them to here. So I have 1/8, 2/8, 3/8. So I'm going to add the 3/8 to the sum of my pieces. It's going to give me 10/8. 10/8 is equal to 1 and 2/8. That 1 I'm going to tack onto there to get 1/30, and 2/8 is a quarter. So the sum of my cuts is 129 and 7/8, plus the 3/8 kerfs puts me at 130 and a quarter. And I got to subtract that from the 144 inches. That 144 is 12 foot times the 12 inches. So 144 minus 130 is 14. But I still got to subtract this quarter inch. So it's going to be 13 3/4. That was a long one right there. Let me do that subtraction again. I'm going to borrow 1 inch from here to make it 143 inches and 4/4 of a quarter. 4/4 minus 1/4 is 3/4. 143 minus 130 gives me a 13. So problem number 18 here is 13 3/4 of an inch of pipe left over when you subtract all these and your 3/8 inch cuts. Hopefully that's okay to read. All right, number 19. What is the radius of a circle that has a diameter of 1.06 meters? Well, that's a vocab question. There's your circle. Here's a radius. A radius is exactly half the diameter, so I need to cut that in half. So 1.06 divided by 2. Well, 2 won't go into 1. It'll go into 10 5 times. And that bring down the 6. It'll go in here 3 times. So half of 1.06 is 0.53 meters. And again, that's really just a vocab question. Oh, wait a sec. So it's 0.53 meters. It wants it in millimeters, maybe in case you get a job in, I don't know, Australia where they use metric. So I got to multiply this by 1,000. So 0.53 meters is 530 millimeters. Okay, what's the circumference of a circle having a diameter of 12 feet? Well, these are a little tricky. These are just equations you have to know. Circumference of a circle is equal to 2 pi r, where r is a radius. Circumference is all the way around the outside. 2r is the same as 2 times the radius is diameter times pi. So you could use the diameter and multiply it by a number pi, or you could do radius times 2 times pi. So what's the circumference of a circle having a diameter of 12 feet? That's a pretty big circle. The circumference would be the diameter 12 feet times pi. So you could just leave it at 12 pi, or you could do 3.14 times 12, and that'll give you 37.68. You'd use a calculator for that or multiply it out. What is this area of a circle with a diameter of 4.5 feet? This one you'd have to know what area is. Area is equal to pi radius squared. Order of operations are important to know that you square the radius first. So you're going to take this diameter of 4.5 feet and find the radius. Radius is equal to half of that, so the radius is equal to 2.25 feet. And then you'll plug it into this equation. Area is equal to pi radius squared. I think you probably use a calculator on these. The important thing here is that you square that number. If you can't use a calculator on these, you could do the long multiplication like we did. So we're going to take 2.25, and here's the square button right here. 2.25 squared equals, that's 5.06. Multiply, and see in blue right there is the pi, so I'm going to hit times pi, and I get an answer of 15.9. So 15.9 is 21. And don't forget, we're in feet. Because we square the feet, this is square feet. Up here, this is circumference around the outside of the circle, so this is linear feet. And I'll do that one on the calculator too. I got 12. I'm just going to put the pi key in there, which is right there, second pi, and that's where that 37.68 came from. That's actually keeping more significant digits, and that's why it's a little higher. But, all right, last one on the page. Last one on the page. What is the area of a right triangle? I can't really figure these out until I have a picture. Area of a right triangle with a base dimension of 3 feet and a height of 4 feet. 1 tick mark for feet. Area of a triangle is base times height divided by 2. So in this case, whoops, sorry, off the screen there. I got to draw that picture, 4 foot by 3 foot. Area of a triangle is base times height divided by 2. I'm even getting tired, take a break. 4 times 3 is 12 divided by 4 times 3 divided by 2 is 6. So the area is 6. These are feet and feet, so 6 square feet. So 22 is 6 square feet. So we're on the 23 in the Plumber's Apprenticeship Math Exam Review. It's actually a great math test, for really any apprenticeship test. I'm going to start using a calculator now. I know this is really hard to see, it's so small, but this is 78 inches. This is 36 inches. This is 78 and 36. That would be 78 as well. So now we're going to have two. Surface area is how much paint it would take to paint the outside of the box, or how much cardboard it would take to make it. Volume would be how much stuff you could put inside the box. So this square right here, or this rectangle right here, is going to be 78 times 36, base times height, 2808. And then I have two of those, so I'm going to multiply that by 2. So this face and the back one are the same, and they add up to 5616. Then the top right here, The top is going to be 78 by 78. So I'm going to go 78 times 78. Top and the bottom are the same. So I'm going to multiply that by 2 to get 12,168. And then lastly, I got to do this face and the side opposite it. So that's 36 by 78. So 36 times 78 times 2 for the front and the back puts it 5616. Probably easier way to do that. So I'm going to add those 6 sides together. 5616 plus 12168 plus 5616, and I get a total of 23,400 square inches. All right, next one down. Calculate the volume of the cylinder. Volume now isn't going to be how much metal it would make to be the can. It would actually be how many beans fit into the can. So volume, I got to find the area of this circle right here times the height. Now it's hard to see, but the diameter is equal to 1.3 meters. And area of a circle is area is equal to pi r squared. So area is equal to pi r squared. We got the diameter, we want the radius. So we'll go 1.3 divided by 2. There's my radius. I got to square that. So 0.65 times 0.65, that's what squaring is. It's going to get smaller because it's less than 1. And then I'm going to multiply that by pi, which is 3.14. I could use the pi key or not. So the area of that circle on the bottom there, area of that circle is equal to 1.32665. That's the area of the circle. Then to find volume, that says 2.8 meters. I multiply it by the height of the cylinder. So I keep that value in there. I multiply it by 2.8, and I get a volume of 3.71 5 or 8. And these are meters. It's all meters, so that's cubic meters. Okay, then what's 12% of 63? What I do here is I convert that percent into a decimal. I remember this thing is like an arrow shooting it over 2 places, so 12% is the same as 0.12. So 12%, I move the decimal over 2 places to get 0.12. So I could go 0.12 on my calculator, 0.12 times 63, and that gives me 7.56. You could do these without a calculator, following the process I started before. Next is 17 is what percent of 26, so it's a fraction. 17 over 26. So I'm going to do 17 divided by 26, and I get 65, or 0.65. 0.654, and then I want it as a percent, so I move it over 1, 2 to get 65.4%. Or I could just round that to 65%. All right, 2 pages to go. Making some progress here. 12.9 is what is 15% of what number? This is saying what number, so we're going to call that number x, what number times 15%, or as a decimal, 0.15, what number times 0.15 is 12.9. So the way to solve that, I'm trying to get this thing by itself, so I divide both sides by 0.15. Divide both sides by 0.15. Those cancel. X is the number I'm trying to figure out. And then I have 12.9 divided by 0.15, and that gives me 86. So 15% of 86 is 12.9. That's a hard one. Just the wording's really hard to figure out on that one. All right, let's do a couple more here, and then we'll go to the last page. An item sells for $63.59. What is the total cost for the item after 7% GST and 6% PST? So we have $63.59. I'm not too sure what PST is. This is goods and sales tax. I don't know if that 6% gets added on to this. I doubt it. I think it's just this and this get added on to that. So that's 13%. So 13% tax, I'm going to multiply by 0.13. That'll be the total tax. So if I multiply by 0.13, that'll give me the total tax. So I can multiply by 1.13, and that'll give me the total cost, right? So the one in the front of that will keep the 63.59 and then add the tax to it. So I'm going to take 63.59, multiply it by 1.13, and I get 71.86. So $71.86. It's a dollar amount. Yeah. All right. There's 28, 29. What is the square of 11? So the square of 11 is saying 11 squared, and that square means it times itself. So 11 squared is 11 times 11, or 121. The reverse of a square is a square root. The reverse of a cube on this one is a cube root. So find the cube of 5. That means 5 cubed, 3 sides. 3 is equal to 5 times 5 times 5. 5 times 5, 25 times 5, 125. And I'm sure. And then find the square root of 49. So it's saying what times itself is equal to 49. The square root of 49. What times itself is 49. 7 times 7 is 49. So the square root of 49 is 7. All right. And then here it is, a cube root of 216. This is saying what times itself is equal to 216. Or the math notation is like a square root of 216. But to say it's a cube root, you put a 3 there. So it's saying what times itself equals 216. I think it might be a 6, but I'm going to check it on a calculator. 6 times 6 times 6 is 216. I only know that because I teach math. The only way to really do that is kind of trial and error, or use the cube root function on the calculator. Write 16%. Write 16% as a decimal. Well, remember, we're just going to move it over 1, 2. So that's going to be 0.16. And as a fraction, that'll be 16% is 16/100ths. And then reduce that. That's going to be the same as 8 over 50. I cut them each in half. Cut them in half again. 4 over 25. 4 won't go into 25. I can't reduce it further. So the answer is decimal 0.16, reduced fraction 4 out of 25, or 4 over 25. All right, coming to the end. I'm hoping this makes sense. If you're still there, congratulations for working so hard. I'm impressed that you're getting it done. That's always good. If you like this, it's a practical math channel. So if you like it, think about hitting subscribe, hit like. Like to hear your comments before and after the exam. See if you did well. Okay, 3 more problems here. Convert 1 million as scientific notation. That would be 1.0 times 10 to the power of, you got to count these zeros here. I got to draw this a little bigger. Count these zeros. It would be 1 times 1, 2, 3, 4, 5, 6. So 1.0 times 10 to the 6 or you could just, convert 0.0001 to scientific notation. This is going the opposite way. So this would be 1.0 times 10 to the negative 1, 2, 3, 4, 5 times 10 to the negative fifths. Again, that's 0.1, 2, 1, 2, 3, 4, 5. So I'm counting them over here. 1, 2, 3, 4, 5. I'm going to the right, so it's 1.0 times 10 to the negative fifth. And lastly, solve this equation. With this equation right here, let me rewrite it here, is the square root of 16 plus 9 plus 16 quantity squared. So this is about order of operations. The mnemonic device for that is PEMDAS. That's what they're checking here, if you know what order to do them in. Parentheses always go first, then exponents, then multiplication, then division, then addition, then subtraction. So I'm going to do these parentheses first. 9 plus 16 is 25. Then I have 25 squared. I do exponents next. 25 squared is 625. And then this is saying the square root of 16. Well, that's saying what times itself equals 16. That's equal to 4. So then I have 4 plus 625, or 629. Bada bing! All done there. All right, well, I sure hope this helped. Good luck on your apprentice exam. Plumbing's a great trade. You make it through the exam and the apprenticeship. I'm sure you'll have a wonderful career doing that. So I appreciate you watching. Thank you. Good luck. Good luck on your exams.